In this class, we are going to discuss about nucleus structure and binding energy of a nucleus. So, first of all, I will say what is a nucleus. Actually, Rutherford discovered atomic nucleus by alpha ray scattering method, and from this experiment, he suggested that the atom consists of a very small nucleus of the order of 10 to the power minus 14 meter in diameter and surrounded by orbiting electrons. And so, from Rutherford scattering experiment, we come to know the following points. Number one, all nuclei are positively charged because this is the nucleus, and nucleus made up of protons. These are the protons and these are the neutrons. And according to the experiment, we know the charge of the nucleus is positive, but we can calculate the value of the charge of the nucleus because a nucleus made up of protons and neutrons, and protons carry positive charge and neutrons is charge neutral particle, so the charge of the nucleus will be positive. So the charge of the nucleus, the magnitude of the charge of the nucleus will be Z into E. Z is the number of protons. Number two, from the alpha ray scattering method, he suggests that 99.9% of the mass of an atom is concentrated at the central core called the nucleus. Almost whole mass of the nucleus is concentrated at the center, and it is called the nucleus. Okay, and nucleus is made up of protons and neutrons. Third, the radius of the nucleus of the order of 10 to the power minus 14 meter. He suggested the value of the radius of the nucleus about 10 to the power minus 14 meters. Okay. A nucleus is represented by that. This is our nucleus, where Z denotes the number of photon and A mass number. Mass number means the number of protons plus number of neutrons. What are these? Actually, the protons or neutrons are not different physical entities. Actually, they are the different charge states of a same physical entity called nucleon. There is physical entity is same, and the physical entity sometimes manifest as proton and sometimes manifest as neutron. So proton and neutrons are not different physical entity. The mass of the nucleon about the value 1.67 into 10 to the power minus 27 kg, and this is called 1 atomic mass unit, and this is the unit by which we measure mass of all the nuclear particle, 1 atomic mass unit. And according to the Einstein mass energy relation E is equal to mc square, we can say that the mass and energy of a particle are not independent to each other. They depends on one another, and they related by the equation E is equal to mc square. If mass of a body is multiplied by the c square, where c is the velocity of the light, then we get the energy corresponding to that particles. So this amount of mass can be transformed into form of energy by multiplying the c square, and the value is about 931 MeV. And this is the one atomic mass unit. Next, I will talk about size of the nucleus. Since the nucleus is made up of protons and neutrons, and they are called nucleon, and so total number of protons and neutrons is called the mass number. Actually, this is the number of nucleons in a nucleus, and the size of the nucleus depends on the number of protons and neutrons in a nucleus. With increasing the mass number in a nucleus, the size of the nucleus will be greater. So the volume will be proportional to the mass number of a nucleus. And if we assume the shape of the nucleus is spherical, actually we always assume the shape of the nucleus is spherical, and we know the volume of a sphere is 4 by 3 pi r cube, where r is the radius of the sphere, and this is proportional to the a, or r proportional to a 1/3, or finally we get r equal to r0 a 1/3. So this is the expression of the radius of a nucleus. Thus the radius of a nucleus depends on the number of protons and number of neutrons in a nucleus. Here r0 is the nuclear parameter, and the value is 1.2 Fermi. Fermi means femtometer, and the value is 10 to the power minus 15 meter. So the r0 is equal to 1. Actually, the r0 varies from 1.2 to 1.3 10 to the minus 15 meter. For lighter element, the value of r0 about 1.2 Fermi, but with increasing mass number, the value of r0 slightly changes and becomes almost 1.3. So the r0 varies from 1.2 to 1.3 Fermi. Now I will talk about density of a nucleus. We know the density of a body equal to the mass of the body by volume of the body. So nuclear density equal to nuclear mass by nuclear volume. And since nucleus is made by proton and neutron, and if let us consider a nucleus, and in the nucleus there is total number of protons and neutrons equal to a, and since the nucleus is made by protons and neutrons, so the mass of the nucleus will be total number of nucleons into mass of each nucleon, and here Mn is the mass of each nucleon, and it is constant, and the value is 1.67 into 10 to the power minus 27 kg, and 4 by 3 pi r cube. So if you substitute the value of the expression r, and we get, and here since both in upper and lower terms there is a, so it can be ignored, and finally we get the expression of the density of the nucleus is this, and the value about 1.7 and 10 to the power 17 kg per meter cube. Thus the density of a nucleus is independent with the size of the nucleus, does not depend on the mass numbers. Okay, so for any nucleus the density will be same, just like a liquid drop. So we can compare a nucleus with a liquid drop, because for a particular liquid does not depend the density of the drop with size of the drop. What will be the size of the drop? The density will be same. So we can compare a nucleus with a liquid drop. Now I want to discuss about binding energy, and this is very important terms, and without the knowledge of binding energy we cannot understand the nuclear physics. Let's see here a nucleus having Z atomic number and A mass number. Atomic number already we have discussed. Z proton number of proton, and A the mass number. Mass number means proton number plus neutron number. So A minus Z is the number of neutrons. So it may be expected that the mass of the nucleus is equal to the mass of the constituent particles. So the mass of the nucleus should be this, because here Z number of protons are there, and if we consider each proton having mass mp in free state, so the total mass of the protons is Zmp, and A minus Z number of neutrons are there, so the total mass of the neutron equal to A minus Z into Mn, where Mn is the mass of a neutron in free state. So the total mass of the nucleus should be this mass of the constituent particles. But we found experimentally the mass of the nucleus is mz, and always the experimentally found mass of the nucleus is smaller than the mass of the constituent particles. And the difference between these mass of the constituent particles and experimentally found mass of the nucleus, and the difference is called mass defect, and this is very important term, mass defect. This amount of mass is disappeared when the nucleus is formed by combining proton and neutron. Actually, when the nucleus is formed by combining protons and neutrons, this amount of mass transform into a energy and release into the atmosphere, and due to which a attractive force is developed in a nucleus, and by the force all the nucleons in a nucleus are held together, and this is called the nuclear force, and it is the strongest force in the universe. And what are the characters of this force? Here, see the point. The force is, nuclear force is charge independent, because in a nucleus there are proton and neutron. Proton carry positive charge, so equal charge repel to each other, but the nuclear force is attractive in nature. That means the nuclear force does not depend on the charge of the protons, so the force is charge independent. Number 2, the force is short range force. Short range force means one nucleon interacted with limited number of nucleons, so the force will be saturative in nature. One nucleon interacted with limited number of nucleons means the force will be saturative. Number 4, these forces must become repulsive for close distances of approach of the nuclear particles. And otherwise, we cannot consider a stable nucleus without considering the repulsive force. Otherwise, the nucleus will be collapsed. So, these are the character of the nuclear force, and this force mainly develop due to the disappear of mass. This amount of mass is disappear when the nucleus is formed and released into the atmosphere. So, to separate the constituent particles of the nucleus, again this amount of energy must be supplied to the nucleus, and this is called the binding energy. So what is binding energy? The binding energy is the minimum amount of energy must be given to the nucleus to separate the constituent particles of the nucleus completely. Now, I want to calculate binding energy of a one nucleus. Let's see. Let's see here one example. I want to calculate the binding energy of a nucleus, and here I consider the nucleus is 1H2. Actually, this is deuteron, and the nucleus has one proton, and mass number is 2, means number of neutron equal to 2 minus 1 neutron. So, in the nucleus there is one proton and one neutron, and we know the mass of a proton mp equal to 1.007276 atomic mass unit, and the mass of neutron mn is equal to 1.008665 atomic mass unit, and experimentally determined mass of this nucleus is 2.013553 atomic mass unit. But the mass of the proton plus neutron, after adding these two mass, we get mp plus mn. This is equal to 2.015941 atomic mass unit. So the mass defect delta m equal to mp plus mn, since in the nucleus there is one proton and one neutron, so this is the mass of the constituent particles minus the mass of the nucleus is m1h2, and after substituting the value of mp and mn and the experimentally found mass of the nucleus, we get 0.002388 mass unit. This is the mass defect. So this amount of mass disappear when combine one proton and one neutron to form a deuteron nucleus, and this amount of mass is disappears. So the energy corresponding to this mass delta m c square, and this is equal to 0.002388, and this is called equal to c square atomic mass unit 931, and this is equal to binding energy, and the value is equal to 2.23 MeV. So this will be the binding energy of the nucleus. So to separate one proton and one neutron from the deuteron nucleus, this amount of energy must be given to the nucleus. And most important thing is that the fractional binding energy, and this is Fb equal to binding energy. If the binding energy represented by Eb, so Eb by the mass number, here mass number is 2, and this is equal to 2.23 by 2. This is almost 1.11 mega electron volt. And this is the fractional binding energy. And fractional binding energy is very important to study about stability of a nucleus. With greater value of fractional binding energy, the stability of the nucleus will be greater, and it depends on the mass defect. And obviously, with increasing the number of protons and neutrons in a nucleus, the amount of mass disappear will be greater, so the binding energy will be greater, and the fractional binding energy will also be greater. But since a nucleon interacted with limited number of nucleons, so the value of the fractional binding energy will be saturated. Okay, and we will be discuss in the next class about fractional binding energy and about stability of a nucleus depending on fractional binding energy, and also for which value of proton and neutron in a nucleus the fractional energy of a nucleus will be greater. And from this I will be calculate the corresponding binding energy, and after formation of the nucleus, which amount of energy released in atmosphere, that means the fission and fusion process also will be discussed in the next class. Okay, thank you.